Franz here, Clay Manufacturing. I was getting ready to do some test cuts because I'm planning on making some soft jaws, and this is going to go on the website. And I thought, you know what, why not kind of go over the process of how I just mark my material, what I use to make lines with, the material, where I get it, what size I start with and why, and what I actually use to cut the material, and hopefully a finished product. So why am I doing this test program? I'm trying to make some soft jaws because I'm working on the Wasabi Speed Wrench project. This is the next one I'm going to post for free. This is my little Fusion model, and while I'm here, of course, I'm going to plug my website. These are ones I have full information on. This is a work in progress. I have, as you can see, the top side machined. I haven't released the video for it yet because I want to make sure everything's proofed out. And then right now I'm also going to do soft jaws, because to do the back side on this puppy, we're going to make soft jaws. So we'll have to machine a cavity, flip it over, stick this puppy in it, and machine this hat off and the features in the back side. So before I release this, I need to make some little soft jaws. These are just blanks, and then we can get to making our whole assembly right there. Let's hop on over to Fusion. So this is in Fusion. I'm going to close that out. Let's make this a little bit bigger, and let's look at what I'm doing. Here is my soft jaw blank. I'm going to very soon, within the next few days, post a CAD and CAM tutorial on this one. On these soft jaws, very typical to do a little slot back here. If you look, I still have my old thing in here, darn it. If you look at a Kurt vise, this is just a counter bore, it's not slotted, so I can't take a hard jaw and flip it over. The center, the hole won't align with the bolt hole. So when you put a little slot in there, you can use both sides of this soft jaws. This is nothing new. I'm not a genius for doing this. I'm just kind of explaining what I'm doing in case you haven't seen this before. I've done it plenty of times on HAAS VF1s, and I'm going to do it with my mini mill, so I had to change some feeds and speeds. I'm trying to really keep it simple. I only have a 10 tool changer, and I don't want to have a bunch of different tools. So ideally, I would have a 1/2 inch drill, but I don't have a 1/2 inch drill, and I don't want to change it out and buy one. So I'm going to use the biggest one I have in the machine, which is a 250. So I'm going to pre-drill it. Then we're going to pocket it out, and then we're going to do a contour, and then when it's all said and done, we're just going to have some counter bores, some slotted counter bores in this extruded aluminum. Now this extruded, this is 1x2. I bought it from a local supplier from Big R Metals. I bought 12 feet of it. They cut it. At the time I had a car, so they had to cut it in a couple pieces. They didn't charge me for the cut. The total price was $177. And they were very awesome to deal with. And this is one of the pieces that are cut. And I'm going to cut it down to 6-inch lengths. My soft jaws, these are kind of what I'm also going to call quick and dirty soft jaws. The only machine features I'm going to have are these pockets right here. I'm not going to clean up the top. I'm not going to clean up the saw cuts. I don't need to. And in other videos, I'll explain why. All I'm doing is I'm going to cut this thing down to size, and then I'm going to drill those holes in it. And I will on my machine. This is a part I made too. I might turn something like this into a project. I did kind of mimic the design of Edge something. So if I post a similar project, it won't be the one to replicate like what Edge is doing. But this is a work stop I made. This bolts to the back of the vise. This is my X stop. And that will go back here on the vise. And I'm going to set it up so I don't have to refine my X. Now on a mini mill, when you have this bolted to the back, you need to be careful, because if you go all the way Y positive, it will crash into the sheet metal. As it is, this vise barely fits in here, this full-size Kurt DX6. So you got to be careful with that. And let's see, what else? All right, how am I going to measure this out? I'm just doing onesie, twosies cutting, so I'm going to do the slow Neanderthal way. I have this cool little DeWalt tape measure. I love this little guy. It's got a magnet on it. The units are in inches on both sides. I I do like Milwaukee, but they have one size that is metric and the other is imperial. I prefer imperial because that's what I use. Plus, it's the only measurement system that matters. Am I right? Am I right, people? JK. Okay, let's see if I can do this with one hand. Let's put you through this. I'm going to do 6 inches. And it's best when you cut in the saw to lay it flat. It kind of takes out the inconsistency of the saw. What I'm doing, since this doesn't have to be super precise, is I go to my 6-inch mark, and right on that graduation, I put my Sharpie mark right in the center line. I put it right in the center line of the graduation. And then I take my little square, and I'll just follow. I'll create the line based off of that little mark that I made. So here we go. We have my line at 6 inches. Let's see. I did kind of a bad job. I try to, you see my little dash I did was right. I try to put my center of my Sharpie in the center graduation mark. I might kind of make it a little bit thicker, but honestly, if I'm plus or minus 100 thou, I'm okay with that. So this is pretty good. This is my bandsaw. It's a horizontal bandsaw. This is an Ellis 1600. This thing is awesome. My friend Mike, he found it for me on Craigslist. It was 15 or 1600 bucks. I want to say 1500 bucks. It's a little beat up. It makes some weird noises, but these saws are phenomenal. If you can't afford an automated saw, this is very good. This is the best like manual saw I've ever used. And this one, it was a little beat up, but it's worked fine. So here we are. Here's my little kind of outfeed. Now, if you're doing a ton of parts, you really need to have a stop that's clamped here or a stop that comes out and holds your position so you don't have to mark off each one, because this is super efficient what I'm doing. What I did is, before I started filming, I set this roller so my part, where if I push, I can push it down a little bit right here, and I know it's flat on this material. If I went too high with this, and I couldn't push down on the end, then I'm going to be cutting at an angle. So if anything, I kind of will fault on having this roller a little bit on the low side. So when I rest my blade on here, it will push it down and make it flat. And I'll try to show you what I mean right now. Maybe. We're working with this jobby here. Okay. This is more difficult than I thought. I'm going to release all the pressure right here so my saw will drop. And I'm doing this one-handed, so it's not ideal. Let's see if we can get you in position. And with the magic of movies, we'll speed it up. All right, there we go. So I'm going to lift this up, slide it over, and if I set it right there on the center, if I set my blade right on the center like that, it's going to make my part too thin, because there's a kerf there. It's going to remove, I don't know, probably like 50, 70 thou in width. So I want to make sure I go to this other side and I make sure that the very furthest part sticking out of one of these teeth are going to be in the center line of my part where I drew where that graduation mark was. So right now, it's too far over. It'd make my part a little bit short. Let's see if I can fiddle-faddle with this a little bit more. Now I don't cam that over all the way. I just put some pressure on there. It doesn't need to be super tight. And as you see right here, the part of the tooth that sticks out the furthest is right about on the center line of that Sharpie mark. And with this thing, I'll lift the blade up off the material. I'll turn it on. And then I just gently lower it on the stop. And I can adjust the down feed rate with this knob right here. This is our complete cut, and now I can just remove my part. 6 inches on the money. I can usually cut within about 10 thou on that saw. Right here I was a little heavy, I was 6.019, but that's pretty dang good for a manual saw. Next up, I gotta load this onto the vise. I will mount it to the back. I'll find my X, my Y, and I'll find my Z. I almost forgot. I totally need to cut another one. I know you're going to think I'm lying, but this one was 6 and 13 thou. If I could, and put it on there. Whoa, actually. I know I'm not measuring it super awesome, but that one's like pretty good. I was reading a little higher earlier. I don't know. I'm not getting a very good accurate measurement with one hand. This one's a little bit smaller. My point is, that saw is dang impressive if you just take a little time in setting up your cuts. And I want to show you how beautiful the cut is as well. This one, I went a little bit faster on this side. You can see a little build up in here. This is the other side. So this is my second cut. This whole piece is my second part. So basically the first cut you saw. This is the other side of that cut. And this is from the metal supplier. I think they use like one of those carbide tip saws that rotate real fast that are scary as heck. Now I'm just going to deburr those things, set them up in my machine. My next part will be machining them. Here is what the setup looks like. So when you put a work stop in, I like to mount the work stop first, get everything tightened up, get it all lined up while this part is still loose. I get all this tightened. Once this is all tightened, I then slide my workpiece into the stop gently. I hold it down while I tighten the back of the vise. And then I just gave it one little tap with a dead blow just to seat it on my parallels over here. Yeah, right there and there. And that is what the stop looks like. And now if I jog my Y too far positive, I will smash this right in the sheet metal. Right now you can see I haven't done it yet, but if you see me in the future and it's all gouged up over there, you know what I did wrong. And let's see, the only thing with a work stop, I need to chase this thread all the way through. I have a set screw over here and they're little 1/8 inch Allen, so I'm going to probably make a new one that either just mounts to the table. But the nice thing about something like this versus the Kurt one, which I love the ones that sit in this groove, I really like them, but when you have a piece that takes up the whole length of the jaw, you can't use it. So you either need something that mounts to the back of the vise like this, or one that mounts to the table and then holds a position. The only reason I'm putting a stop up is so I don't have to touch off X again. And honestly, with my Heimer and the time it took to build all this, it actually would have just been faster to set it with my Heimer, but whatever, we're learning here. And yeah, so the next one is going to be me trying to cut this thing out, and hopefully we don't have any problems. I'm going to about 1 inch and 10 thou. Math says I should be right. We're getting there, but it's just, it's scary. Especially the flood coolant, so we'll see how it goes. This is the second pocket. I don't know if you can hear it, but my compressor's going. Someone wanted to hear it run. The spindle on this at 6K has a real high frequency pitch, but yeah, it's not terrible. It's definitely louder than talking voice. Looking like a soft jaw. I got a couple feeds to tweak a little bit. I'm going at like 30 inches a minute on that big pocket, and it's a little bit fast for how deep I am on this little guy. I'm using a 3/8 end mill. That's kind of my go-to on this. I'm going to make a couple updates, and then we'll run the other one. But everything went okay. This is the first jaw. And then this is the second jaw. I need to run it. And what I like to do when I'm doing these jaws, I'll find whatever surface is the nicest and I will put it down because I want that to be my backside. So when these soft jaws are installed to the vise, This is the side that's going to come in contact with the vise, so I just look for the cleaner side. This side is going to be facing the part, so if it's got dings in it, it's not really a big deal, because later we'll cut in the geometry that we want in this thing, so I don't really care. Some people will go above and beyond and square it all up. I really don't have time for that, so I don't waste my time doing that. And then we come over here to the beauty of my work stop. I have my parallels in there. I find the prettiest side that has the least amount of damage, because I want that to be on my reference plane. And then this guy will go right in here, and I'll slide it to my work stop. I'll hold it down as I tighten the vise. I torqued it, and what I'll do to make sure it's sitting flat is I'll kind of pull on the parallel, and if I can feel it slide a little bit, it might have lifted a touch. I don't go crazy with a dead blow. I'll just give it a little tap, because this is an extruded piece of aluminum. It's not machined and precise. So if a little tap didn't seat it, so now it's a little firmer where that doesn't wiggle, neither does that one. But if it wiggled a little bit, I can kind of push it, but it's got some resistance. You can get a piece of like banding, steel banding, to act like a spring to keep those spread apart. And it might be a good idea, so, because if a parallel works its way under here when you're drilling through, you're gonna wreck that drill or that end mill. I ran the first program. This is my second version. So I'm gonna go ahead, I'll just close this. We will let her rip. I'm gonna come over here. I'll turn it to 50% rapids. It's white, means it's on, it's active, and I'm just gonna go cycle start, and we'll let her rip. It's gonna go grab my drill. This is my it's a little under 250 drill, but I call it a 250 drill. And I changed kind of the pecking depth on it. It starts to bind up just a little bit at the bottom. This is a high-speed steel drill. It's drilled quite a few holes, so it's probably getting a little dull. Now it's going to call up the 3/8 end mill. And that thing is barely sticking out from the nut, barely more than an inch, so it gets buried pretty deep. And that's kind of doing the helix around that drill hole. Ideally, you would have a drill hole that's bigger than the diameter of that tool, and you can just plunge straight down and then get into the adaptive tool path. Helix are extremely slow. A drill bit is far more efficient at removing material straight down than a end mill is. Now this is the adaptive feed rate at only 20 inches a minute. This is a chamfer. In the program, I need to edit my post so it kicks my table to the right. I haven't done that yet. And this is my new one with a few updated feeds and speeds. I'll still probably, if I'm posting it, well, I am going to post it publicly, I'll probably tune it down just a smidgen, because it still sounds a little bit aggressive, because it's the surface speed of the outside of the tool, and it's a real small diameter. And so it makes it haul and load it up really easy. Get a little up close look. This is jaw number 2 with my updated feeds and speeds. This is jaw number 1. You can kind of see a little more linear feed rate, the feed lines in there. Still not bad, still looks okay. That's my chamfer. I did a 20 thou chamfer on the top. Here's the other side. And just for another comparison, I follow up. I did a pocket, and I followed up with a contour. With chamfers, I try to do a horizontal lead-in radius so you don't see witness marks as much. This is what the back side looks like. And I have not hand chamfered the back. So this stock actually is 1 inch and 10 thou in thickness. And so I always go like 10 thou past the bottom to make sure stuff gets cleaned up, but I almost didn't go far enough. And my 3/8 end mill is just barely it's barely far enough sticking out of the tool holder. But here we go. This is a cheese. I will be posting these up soon if you want to do a sneak peek to look at my dimensions. I just got to double check. I've made them before. These are slight different ones from ones I've made before. This radius is a little bit different than my old one, so I guess I just got to mount them to my vise and double check. But the idea is this jaw will replace that back steel jaw so I can machine my own geometry into it. All right, now I'm out of here. Have a good one. Bye.